We're going to do a small review on classes before going more in depth on some of the specifics of classes. By now, we should be quite familiar with creating and using classes. In the example above, standard vector is a class. One function is called on the vector itself, while in the other one, the vector is passed into the function. This is because .size is a member function of standard vector, so it can be accessed by using the dot operator on the variable, while standard min element is not. Beside member functions, we can also have data members, which can be accessed through the dot operator. For example, we create a variable position with type position, and then we standard cout position.x, and here x is a data member, which we access by using the dot operator. Now that we've done a quick review on how to use classes, what is a class? Hopefully, we have quite a good sense of what a class is, but more specifically, a class is a tool we can use to encapsulate state and abstract away details. Now this is a mouthful probably, but in essence, one example of an encapsulation would be when we want to use an LED. When we want to use an LED, we don't need to know how the LED turns on or off. We just need to know that we can turn it on and off. This is what encapsulation is, hiding away details that are not necessary to use it. Now, it's time to write our first class. To declare a class, we need to use the class keyword. For example, here, we declare a class called empty class by using the class keyword and then the name of the class, and then curly braces. Now, of course, the previous empty class is not that useful. Let's say we wanted to write a class that represented a 2D position. Since every 2D position is defined by x and y coordinate, the x and y coordinates are part of the state of the class, and we can include them as data members in the class by declaring them inside the body of the class. So here we declare double x and double y, and both x and y will be data members of the position class. Data members can be default initialized during declaration by providing it a value. In this example, we initialize both x and y to 0 by assigning it the value 0 during declaration. Now that we've written the class, you might try to use it like this. For example, creating a variable called position of type position, and then setting position.x equal to 10. However, this will give you a compiler error, saying that int position : x is private within this context. What's going on? So we're getting this error because the data member in x is private. We'll go more in depth on what private means, but basically it means that you can't use the data member unless it's inside a member function of the class. Classes that are defined using the class keyword have members which are private by default. Besides using class, there's actually another way of declaring classes in C++ using the struct keyword, which is helpful to us here as it has public members by default. Classes constructed with the struct keyword are done the same way as with the class keyword. For example, to create the same position class as earlier, but using the struct keyword instead, we simply replace where we use this class keyword with the struct keyword, and everything else stays the same. Except, of course, that the data members are now public instead of private. Unlike private members, public members can be accessed by anyone. This means that this example now works, because the data member x, or position, is now public, and so we can access it and set it freely. One of the biggest points of an encapsulation is being able to use something without knowing the details. Let's say we wanted to add numbers to a list and get the running average. We could do it using standard vector and make use of the handy standard accumulate function. For example, here we create a vector nums of type double, we add 3 numbers to it, and then we calculate the average by doing standard accumulate, and then we divide by the size of the vector. And then we can also add an additional number and then recalculate the average and then print it out again. If we need to use it often though, we could create a moving average class that abstracts away the details of how the average is calculated. The first thing we need to do when creating this moving average class is to add the data members. Since our state only consists of the vector of doubles, we add that as a data member to the class. Notice that we use the curly braces after the data members in order to initialize the data member, in this case the vector, to its default value, which in this case is just an empty vector. We'll go over initializing data members in more details in a later video. For our member functions, we have 2 main ones representing the 2 main things we want this moving average class to do. The first is that we want to be able to add new numbers to the class. The second is that we want to be able to find the average of the numbers. We can declare these two member functions like so. Declarations happen in header files, so the code that we wrote just now would probably live in a file called movingAverage.h, and the definition would be in something like movingAverage.cpp. Let's write the definitions for this class. The definition will look something like the ones above. Notice that we use the scope resolution operator to define a class member function, similar to how we would use it to define a function inside a namespace. If we didn't use the scope resolution operator, then we would simply be defining a function that lived in the global namespace instead, and the compiler would complain that the member function was not defined. Similar to normal functions, with the declaration and definition separated, anyone who wants to use a moving average class can do so by including the header file. With the moving average class that we just created, we can create an instance of the moving average class, call the .add method, and add a few numbers, and then get the average by calling the getAverage method. Notice that by creating a class, we've encapsulated all the implementation details of how we calculate the average, and we only exposed the two functions so that the user does not have to know anything extra about how averages are calculated, only that it can calculate averages.